if I'm looking at this page of notes, right? Distribution of data, so how it's arranged, we can discuss a lot of things. If I have histograms, I want to ask myself, which measure of center or spread should I use to describe what's the best, right? Do I want to talk about the range of the data? Do I want to talk about the center of the data? What word describes the mathematical center?
Median.
The median, right? Or I can talk about the spread, how far it is, the range. Or I can talk about the shape, what it visually looks like. Shape, center, and spread are on here, right? So, is it symmetric? What does symmetric mean?
Is it the same on both sides?
Right, could you fold it in half and have it kind of line up? Doesn't have to be perfect, but be similar to each other. Is the left and the right side similar? If the answer is yes, it looks similar on both sides, you use the mean, the average. If the answer is no, it does not look similar on the left and the right, the median is the better answer. You could use the interquartile range. You could use the absolute deviation here, right? So this kind of gives you a good guidance of which one do I want to talk about. So this is important. Right? It's going to help you. So then if I'm talking about the way something looks, if I'm talking about the shape, here are some things that I could talk about. Look at this. It's almost perfect, isn't it? This is called a bell shape. It's symmetrical. It's ideal. It's normal. It has a bigger spread, meaning a range, right? It takes up the whole graph on the x-axis, so it means that there's a lot of data spread out. This one is also symmetrical, right underneath it. But what's the difference from here to here?
There's less spread.
There's a smaller spread, right? It's still a bell, except it has less spread.
The mean equals the median.
The mean and the median are pretty even. This is the inverse of this guy, right?
Yeah.
Instead of going down, down, this goes up, down, up. It's probably has two modes, right? There are two peaks, two highest points. It's still symmetric, right?
Yeah.
This one, the left and the right are not the same. Do you agree? There's an outlier. Why do I think there's an outlier?
There's one
'Cause
right there.
There's a big old gap, and then this guy's lonely, correct? Down here, still not symmetrical. Do you agree? This is going to be the one that I think is the hardest to remember. The mean, if you added up all of the data and divided by how many pieces, is greater than the median in this graph.
How?
Because there are only a few big numbers and lots of little numbers. So when you add up the data and you have lots of little numbers and only a few big numbers, right? It's going to pull that,
Mean.
right? It's going to pull it. The number in the middle is going to be over here. The average or the middle number is going to be over here, correct? Because I've got a lot of values here and not very many values here, so I'm going to quickly end up down here to find the median. But these big numbers are going to pull those little numbers up for the average. It's the opposite over here. These little numbers are pulling them the other way. So we're going to talk about these different types of graphs, but you can discuss the shape of a histogram by talking about, is there a gap? Is there an outlier? Is it symmetrical? Is it not symmetrical? Skew is something we're going to talk about when we talk about socks in the next part. This is going to be very handy when you are analyzing histograms. Got it?
Okay.